of u. 1 over u. Oh, not u, sorry. So for us it would be 1 over y, but then times the derivative of what's in there, right? What's the derivative of y? Y prime. Does everyone see that the derivative of a natural log of y is 1 over y prime? No one has a question? That's the left side. There's nothing else to do on the left. What about the right side? What do you see happening over here? Product rule. So what's the derivative of x? 1 times ln x plus what's the derivative of ln x? 1 over x. And we don't have to put x prime, right? Times x. So we get 1 over y prime equals natural log x plus 1. And what was the goal with implicit differentiation after you take derivative? You wanted to do what? Get y prime by itself. So how can I get y prime by itself over there? Divide by 1 over y or multiply both sides by y. I'm going to multiply both sides by y. And when I multiply, it has to distribute through, right? So now that is correct, but didn't we have earlier in the problem, we had an equation that told us what y was? Remember this equation up here? It said y was equal to x to the x, didn't it? So what I can do here is I can actually come in and replace these y's with what it's supposed to be in the problem. So it should be x to the x natural log x plus x to the x. The advantage of the second answer is that if you want to know the derivative, that means you want the slope of the tangent line. All you have to give me is an x, and I can give you the slope of the tangent line. As opposed to this one on the left, you would have to give me the x and the y. Y'all see how that works? Logarithmic differentiation, it's a really, really nice technique. I'm going to do probably one more of these, and then I'm going to give you a couple of problems to work on, and we'll take a break afterward, all right? So y'all can sit here and watch me do this all day long. It doesn't mean anything until you sit down and try it, right? Y equals e to the negative x cosine squared x all over x squared plus x plus 1. So before I begin this, let's make sure we are all clear with the fact that we could do this using quotient rule. Right? Don't we have a quotient? And the numerator is actually going to be, how would you take the derivative of the numerator? Like when you tried to set up that f prime g minus g prime f all over g squared. When you do f prime, you would have to do a what? A product rule, and then one of those, cosine squared, is a chain rule. It's kind of a mess, isn't it? Kind of a mess. So what I'm going to do is use logarithmic differentiation. So logarithmic differentiation says that you should take the natural log on both sides of the equation. So let me take natural log of the left and natural log of the right. Now, in the last problem, what was the bringing the log in on both sides? What did it allow me to do? I mean, what was that critical next step that I was able to accomplish? Yeah, I was able to get that x and drop it out, right? That x was able to drop out. Here I don't have that, do I? But there are some other properties of logs that, again, were in my videos that I did. One of them said this. Actually, I have my notes with me so I can tell you exactly what I'm talking about. It's written a little different in the notes. I'm talking about 3.2.3 in the notes. Property 2 says log base a of x over y equals log base a of x minus log base a of y. So it says anytime you have a log and you have a fraction, you're allowed to take it and split it into two logs with subtraction between them. Again, this is a college algebra topic. So can't I treat this whole numerator like x and the whole denominator like y and split it into two logs using that property? So watch my next line. I have not taken any derivative yet. It's going to turn to natural log of e to the negative x cosine squared x minus natural log x squared plus x plus 1. How's that? Any questions there? Now in my notes there's another property that says that log base a of x times y is log base a of x what? Plus log base a of y. So do you see in this first natural log with the e to the negative x, do you all see multiplication between the e to the negative x and the cosine squared? So can't I split that into two logs? Right? Natural log y equals natural log e to the negative x plus natural log cosine squared x minus natural log. Now, can I split this one up, the x squared plus x plus 1? Can I split that into three logs? No, because it's addition, right? You have addition between those terms. The property only works if it's multiplication, so you can't split that one. So we're kind of screwed with that one. Anything else? Does anyone see anything else we can do? Absolutely. The 2 here is really squaring the cosine, isn't it? So that's like a power on the cosine that can be pulled out in front. There's also something I can do in that first one, natural log of e to the x, e to the negative x. I can bring the the negative x out front in front of that, right? I have natural log y equals, it is going to just be equal to, it's just going to be equal to negative x. Because natural log and e are inverse functions, they'll kill each other off. So really, there's two ways to look at this. Natural log of e to the negative x, either they wipe each other out and you can just get negative x, or if you want to look at it this way, the negative x comes out in front and then natural log of e is 1. Either way, you get negative x. But I left it in there to show some of the work here. 2 natural log cosine x minus natural log x squared plus x plus 1. I'll go one more line. So I'm just going to make this a negative x plus 2 natural log cosine x minus natural log x squared plus x plus 1. All right. Questions? You'll never have questions. No one ever asked me. Now, I think now I'm ready to differentiate. Because what I'm doing is I was cleaning everything up to the point where I was happy with it. So I'm going to get up just because I'm tired of sitting already. Look, when I look at this, when I was here, I didn't want to take a derivative. Here, this was still some chain rule involved here, right? Like you have natural log, and inside that you have squared, and inside that you have cosine. And then on this one, well, there's nothing I'm going to be able to do there. But if you have properties you can use them. Exploit those properties. So I bring this all the way down to a negative x. Derivative of negative x can be what? Negative 1. Plus 2 times something. So I'll bring the 2 down. What's the derivative of natural log of something? 1 over that something times. Then go inside. Derivative of the something would be what? Negative sign? Okay. So I'd be done there. And then over here, minus natural log, derivative of natural log of something is 1 over that something times derivative of what's inside. So this is going to be to me, this is a much easier derivative than that quotient rule in the beginning that would have required some product rule, and then in that product rule there was some quotient, there was some chain rule. All right, now what's the derivative of the left side? 1 over y times y prime equals negative 1 plus 2 times 1 over cosine x times derivative of that, which is negative sine x, minus, not natural log, 1 over x squared plus x plus 1 times derivative of what's inside, 2x plus 1. I'm going to clean that up. Sine over cosine's tangent, right? And it's negative, so negative 2 tangent x. And then minus 2x plus 1 over x squared plus x plus 1. And then I'll multiply both sides by y, right? So I'm just going to do it this way. I'm just going to throw that y out in front of all of them. And that would be okay, but did we have an equation that had y in it? Way earlier in the problem. Wasn't the original problem y equals something? All that? So I could come down here as my final answer, y prime equals e to the negative x cosine squared x over x squared plus x plus 1. That's y, right? That is y? Yeah. Times, in parentheses, 1 minus, negative 1 minus 2 tangent x minus 2x plus 1 over x squared plus x plus 1. I'm at the bottom of the page. All I do is replace the y with what y was in the original problem, right? Are there any questions? Okay, what I'd like for you to do right now on your own is I'd like for you to do page 169. Let's do number 9. Number 25 and number 57. So this is just exercise, okay? When you're done with these, take a break. Let's say that I'll give you 15 minutes to do these problems, which puts us at about, what, 2:50 and a 10-minute break. So we're going to say 3 o'clock is when we are going to continue class, all right? It's 2:36, 2:37 right now. 3 o'clock we'll resume. So try and get your 10-minute break in there somehow.